Okay, again, so to look at how the command lines can be passed in from a particular program, we'll have to go out to the DOS prompt and create a file. There. We can go ahead and compile this from the command prompt. Okay, now we can try and run it. And I'll pass a bunch in that comma separated. And basically all it did is it did the same thing. It printed them out from the command line. All the arguments passed in. This is kind of important if you're writing what we call Java jobs, or jobs that get kicked off and you want to pass in some, by a scheduler, and you want to pass in some values. Definitely could be very useful for that. And again, arg sub 0 will be the first argument you pass in. In my case, that was 1. Then 1 sub 1, arg sub 1 will be the second, and so forth. Calculator. Oh, here's one that looks like it was meant to be run from the command prompt. Of course, I have a couple of options here. I can run it from the command prompt. I can also, though, do the same thing that A just did and say use A again, but this time just say calculator name, and we have to actually give it arguments. What are those arguments? So if we look at calculator, so it wants 3 operands, so it wants, okay. And then it's going to compare each one. So this needs to be 2. This needs to be a plus sign. That needs to be 3. And then we can say calculator main string. And we can do that. We can do all 3 of them. We can actually just run it 3 times if we want. I believe all they're doing is changing the operator. Easy enough to do. All you have to do is say strings 1 change to a multiplication and a division. So you could run this from the command line, or you could just, use this tester thing right here. And then you get the output you expect. Right, any questions so far? Everyone's so quiet. Next thing, we talked about regular expressions a little bit, and we'll just talk a little bit more about it. And then we'll take a little break here and then go over the midterm and answer any questions you have on the labs. So regular expression is basically a pattern. So instead of looking for something exact, like someone whose last name is Smith, exact, you might say, well, I want to find everyone who's Smith, but with any possible spelling. So you've got Smith with an I, and a less common spelling, which is Smith with a Y. And sometimes they put an E at the very end, sometimes they don't. So anyone who's got a name that's like Smith, and all the different spellings. So we looked at some of these already when we matched strings. This basically says anything that starts with Java. We will match that. So we saw something similar to that earlier. But the regular expression syntax you can have is quite complex. You've got quite a few in there. You can look at any character. This will match any single character. It's an OR condition, or 10 matches 10 or Tim. So it's basically either combination of that. Any of those characters will match ABC. Anything but that character. So there's a lot of different comparisons, and we're not going to go through all of them, but there's a good chart. Regular expressions is kind of a little bit of an advanced topic, but it's very powerful to be able to do regular expressions. And that's part of the string class. And this would split it on D, \D. What's \D? Oh, any digit. \D is any digit. Okay. Any questions so far? On this at all? Hold on for a second. Let me see if I can get the. Actually, I think I can get the midterm up. Okay. Let's take a look at. We've got all the questions here, so we'll go through them. What is a sentinel value? this was a type in, and really looking for something like it's a value that would not that's used to terminate a loop, a while loop, that would not be a normal value for valid input. Something like that. A lot of people left that part off, and I was, depending upon what else you said, either let it slide or not. But that should have been there as well. And so for example, if you're prompting the user to enter positive values, the -1 would be a sentinel value because that's not a valid value. And you usually would prompt the user to enter a -1 to end the loop. In your own words, describe variable scope. I was looking for something that said it was can only be used, referenced, touched, whatever, seen, whatever, in the scope in which it was created, which is usually the block it was created in. So if it was created class-wide, that would be class scope, anywhere in the class. Looking at one of these methods here, for example, we would say string temp is class scope. Because it's created outside of the class and anywhere. Strings, on the other hand, would be local scope. Scope would be local because it's created within the method. And that's really what you've got is local scope and class scope. And then you also additionally have something, what we would call block scope. Actually, they're all really block scope, but anyway, if strings.length is greater than 9, let's say, then you're going to do something. And if I create something here, block or something, it's block scope. It cannot be accessed outside here. I can't say block is equal to test because it's out of scope, right? I can say strings sub 0 is equal to test, and I can say temp is equal to test because they still exist. Oh, well, I have to make this one static, but so I can do that. But this block scope is gone, right? Because it was created here in these, and this is a block. So, something along those lines, and most of you actually did give me something along those lines, so you got credit. How is an array passed? It is passed by reference. It's always passed by reference. How is a integer passed? By value. Always by value. Break is valid in all but, I believe that should have been none of the above. Let me see if I can edit the questions. So the question is, it is valid in all but. Okay, so no, it's valid in all of them. It's valid in switch, while, for, do while. It's valid in all of them. So the answer should have been none of the above. C equals C plus plus is equal to, I believe this should have been all of the above. Because C equals C plus 1 is equal to C plus equal 1, C plus plus, plus plus C, all of the above. It's all of the above. So the answer should have been all of the above. Let me know if you have any questions on any of these. Continue is valid in all but a switch statement. That's the difference between break and continue. Break is valid in all of them. Continue is not valid in the switch statement. It's valid in the loops, but not the switch statement. Binary 0110011 is equals which character? I believe that's the letter C, or is it D? Let's see, what did I put? A, B, or C. I think the options were A, B, or C. And C was the correct answer. C was the correct answer. Java is all the above. I believe that answer was all the above as well. Object-oriented, yes. Portable, yes. Multi-threaded, yes. Secure, yes. All the above, yes. So that should have been all the above. Java required code. So the question is, which one of these lines is not required? Given this, which line is not required? Line 3. You have to have class name, you have to have the main method, and you have to have the closed curly brackets for both. But you don't have to have anything. The main method doesn't have to do anything. It's just got to be there. So technically, the print statement is what is not required. Now we've seen it in every program, but it's not technically required. Java course Java source code file. Represents what? It's a source code. No, not the compiled Java program. The Java source file. That's what it is. Public static void main. What is the signature of this method? That's it. And that was one of the options. Right? That's the signature. The method name and its arguments. It's like failsafe. I'm not sure what you mean by failsafe, Angela. Well, it's not really a failsafe. It's just that you want to do something to make sure the thing's running, so you put it in. But it does not have to be there. Storing an int in a double variable is an example of promotion. Should have been the answer on that. String s equals the string 2 plus the letter 3 results in what? It's going to result in the string 23 or 23. The reason being is that string is the universal data type, so the number 3 has got to be implicitly converted to string, and then the plus sign becomes a concatenation. So it becomes the string 2 concatenated to the string 3, which is the string 23, or the string 23. The following are all valid part of the if statement except. Yeah, default. There's no default in an if statement. So, choice 4. Following is not a benefit of methods. I believe performance was the answer on that one. Yeah, methods give you a lot of benefits, but performance is not one of them. Write once, reuse anywhere, that's definitely a benefit. Information hiding, yep, that's definitely a benefit. Reduce complexity, that's definitely a benefit. Improve performance, no, they don't. They don't improve performance at all. They actually degrade it a little bit. Not much, not noticeable, but they actually degrade it a little bit. They definitely don't improve it. Variables and constants are the same, except constants are read-only. Not sure what language I use, but basically they're read-only. Constants have to be uppercase. No, they don't. The standard is to write constants in uppercase letters, but that's not a requirement. Constants are read-only, yeah. Constants are read-only, that's the answer. What is the best loop for doing something a given number of times? A for loop. What is the best loop for doing something at least once, but maybe more? That's the do-while loop. What is the result of int c equals 20% s? Okay, so remember, this is the modulus, or the remainder. So you're going to divide 20 by 3, and you're going to store the remainder in c. And that should be 2. Should be the answer, the correct answer. We'll take a quick look, but that definitely should be 2. 2. Yep. Okay, any questions on the first, looks like 20 questions here at all? Okay, the last 13. Where does Java run? Anywhere and everywhere. Pretty sure that should be, everywhere or anywhere should be the answer. Actually, those web applications, yes. Most browsers as applets, yes. Most smartphones, yes. Desktop GUI applications, yes. All the above. It runs everywhere. Toaster, yes. Car, yes. Your DVD player, yes. Your Bluetooth device, yes. Your Blu-ray device, yes. You name it, it runs. Which is not a valid loop in Java? I think that was the do until loop that was not valid. Yeah, there's no do until loop in Java. Some languages have it, but Java doesn't. Which of the following is not a numeric data type? String is not. I almost threw a trick question at you by making this a char instead of a string, and that really would have been mean, because a char technically is an integer data type. But you think of it as being non-numeric, but actually it is numeric. That would have been mean, so I didn't dare. Which of the following is not an escape character? Let's see what we put here. Let's see. \n is, \t is, \/ is, double quote is, none of the above. They're all valid escape characters. Which of the following is not overloaded? I believe it was none of the above either. I think they were all overloaded. Okay, max. Yep, max with 3 doubles. That would be a form of overloading. Integer would be a form of overloading. Yeah, so they're all overloaded. None of the above. They're all overloaded. What is / double quote? Well, it's / double quote. You're escaping the special meaning of the double quote. So, for example, if I want to come in here and say this is equal to test, and what I really want to do is I want to put double quotes around the word test, I can't do that because the double quote is a special character. So the / takes away the special meaning. So now this will have double quotes inside the string. So the /, the escape character, either gives a character a special meaning, such as \t is tab, or it takes it away. It's one or the other. All right, let's see. Where are we at here? For int I. How many times will this loop iterate? 9, 10, 11. 10. Yeah. 0, 0 and less than 10, so we go 0 to 9, which would be 10. All right, let's see what else we got. Public. What is the return type? Void. What will be the output of the following? Okay, this one tripped a few people up, but the output is B, and this is why you get tripped up on it. This is the whole thing with the dangling if. Which one of these if statements is the else actually for? Now, if you leave it spaced here, it visually appears to be this one, but that's not true. The else goes to the closest if. It doesn't matter where it's indented. And this is the closest if. So it goes to that. So it actually is B is the output. Now, if you wanted it to be for this guy here, what you'd have to do is use curly brackets. Now this else would belong to the first if, because this if is fully enclosed within the brackets. It's a little tricky, but the else goes to the closest if statement. Right? And we can go ahead and we can run this. Let's just get rid of somewhere. I'll just do it here. Don't need that. We'll get rid of this. So now visually this looks like it belongs to that if. But it doesn't. Because the else always goes to the closest if, which is this guy here. So this really should be indented even further to get it right. So we can go ahead and run this, and you're going to just see, no matter where this is indented, I get the same output every time. Okay, why didn't I get the output? If I is greater than J, and it is, and if I is greater than... No, it's not. It's not... Oh, okay. I'm sorry. You know what? It looks like I marked... I did it wrong. It should have been no output. Okay. Now we get B. Because by putting the brackets in there, I forced the else to go to the if. Okay. Sorry. I will have to go back through the midterms. If I marked you wrong, I will give you credit. I meant for the output to be B, but it's not. Okay. Let's look at some of the others coming up here. A literal is a constant value that appears directly in the program. Pretty sure that was true and false, and the answer would be true. True, yeah. And I think these next couple of ones were all true and false. Yeah, I'll have to go through and correct those again. If statements can be nested, that's true. Loops cannot be nested, that's false. Both if statements and loops can be nested as much as you want. String is considered a primitive type, that's false. Write once, run everywhere. This is Java's motto, and it means that you can write and compile the program on Java and run it on any operating system, and that was also true and false, and it's true. That's correct. Okay, that's the midterm. Does anyone have any specific questions on any of these questions?